Lesson 69 is on factoring trinomials, and this is one of the most important things that you will learn in algebra. It's a really important thing to know how to do. There are some really important problem-solving skills to be able to develop in this factoring trinomials. And also, if you're going to be going into any kind of mathematical related degree in college, you'll be using these all through college as well. So it's good to figure them out good now, and it'll make it easier later. Now, trinomial is a certain type of polynomial. Like this would be a monomial, and then we've worked with binomials. That would be like that is a binomial. A trinomial, it just has three terms, like maybe this. That would be considered a trinomial. To factor a trinomial, let's just think of something first. Let's think of a binomial pair that we have as factors. And let's just use an example, x plus 2 and x plus 3. Now those two binomials are factors of each other. And what we've been doing, you've been learning how to expand those binomials. You learned how to do that way back in lesson 49. And you remember what you do is you just look at the first term in the first binomial, multiply it by both terms in the second one. So you take that x, multiply it by the x and the 3, and you'd have x squared plus 3x. Then you take the 2 and you multiply it by the x and the 3, and so you'd have 2x plus 6. Then you can add those together, the like terms together, x squared plus 5x plus 6. Now what you're doing in this lesson on factoring trinomials, see, you've created a trinomial there, x squared plus 5x plus 6. You'll be taking a trinomial and you'll be just doing the reverse. You'll be going back to two binomial factors. That's why it's called factoring a trinomial, because you take the trinomial and you turn it into two binomial factors. So to factor a trinomial, this thought statement that I have down here in red on the bottom, this is what you need to try to remember, and that will help you understand how to factor trinomials. What you need to do is think of two factors for the constant term that, when added together, equal the x coefficient. Now that's a lot of stuff to think about there, and it sounds kind of confusing, so we'll do a lot of practice problems to help you get this concept of factoring trinomials down. Think of two factors for the constant term. So like in x squared plus 5x plus 6, the constant term is just the 6, the one that doesn't have a variable in front of it. That's why it's called a constant. Its value stays constant. The other ones, they have variables with them, so they will vary, they will change, they won't stay constant. And so we want to think of two factors for the constant term that, when added together, equal the x coefficient. And so that's the 5 that I'm circling here. That's the coefficient of x. So that would be a 2 and a 3. That would work, right? Because those are two factors of 6 that if you added them together, they would equal 5. And that's what you put into the binomial pair and to factor that trinomial. Just like that, we have x plus 2 times x plus 3. And so we just put those two factors in those places. We'll have an x and then plus 2 times x plus 3. Then you can expand that out to check your work. You can always do that on these problems. Expand the two binomials that you get back out to make sure that it does equal the trinomial that you started with. So let's go ahead and do some problems. Look at practice problem A. X squared plus 3x plus 2. I want you to factor that into two binomials. So you know, just write down what you know for sure. You know that you're going to have an x and an x like that. You know you're going to start with that. Now, use your thought question here. Think of two factors for the constant term. So the constant term is a 2. That when you add those two factors together, they would equal the x coefficient. So there's only two factors of 2 that we can use, and we're looking for whole number factors here. 2 and 1, because 2 plus 1 would equal 3. So we can say x plus 2 and x plus 1. Doesn't matter if we said x plus 1 times x plus 2. The order there doesn't matter. Let's go ahead and check our work to make sure that we did this right. Take the x in the x plus 2, multiply it by the other x, so that would be x squared, and then plus x times 1 is x. Now multiply the 2 by the other terms, and that would be plus 2x plus 2. And so you see there, we would get x squared plus 3x plus 2, our original trinomial. So this is the correct expansion, or correct factoring, I'm sorry. That's the correct factoring of that trinomial. Let's do another one. X squared minus 4x plus 3. Well, first let's think of two factors for the constant term that when added together equal the x coefficient. That's what we need to be keeping in mind here. And actually, let's just go ahead and make our binomial pair and put our x's in place. And think of two factors of 3 that if you added them together they would equal a negative 4. Well, that seems like that would be impossible. But just think about it. If you had a negative 1 and a negative 3, that would work, right? Because negative 1 times negative 3 equals positive 3. Negative 1 plus negative 3 would be a negative 4. So those are our two factors, x minus 1 and x minus 3. We can check our work to make sure. We'd have x squared and then minus 3x minus x plus 3. And that does equal x squared minus 4x plus 3. So that is right. That's our factored form of that trinomial. Let's do another one. Factor this into two binomials, t squared minus 7t minus 30. Let's make our two binomial pairs first. Put a t here and a t here because that's our variable that we're using. Now we think of two factors of negative 30 that if we added them together they would add up to a negative 7. And so just start thinking 10 times 3, negative 10 times 3, 10 times negative 3. Those would be negative 30. 5 times negative 6, negative 6 times 5, those would also equal negative 30, but those wouldn't add up to negative 7. 3 and a negative 10, that would add up to negative 7, so that's what we need to use. Put a plus 3 here and a minus 10 here. It doesn't matter, we could have put the negative 10 first, but the signs of them are important. We couldn't have said negative 3 and a positive 10 because that would have given us a positive 7t instead of a negative 7t. So this is our factored binomial. Factored trinomial, actually, right? Now, it's important to keep in mind the steps that we're doing here, they only work when your squared value, your x squared or your variable that's squared, it doesn't have a coefficient in front of it other than 1. We couldn't do it this way if we had like 3t squared minus 7t minus 30. And you won't have any problems in the book or on the test where you have a coefficient other than 1 in the front of the squared variable. And also they won't give you any problems where you had to figure out two factors that were decimal values, because that would just get really confusing. All these will be whole number factors, integer factors. You won't have any decimal value factors to be dealing with. Let's do another one. This is t squared plus 7t minus 30. Now that's real similar to c, except the 7 has changed signs. Let's just go ahead and put our binomials and the parentheses in place. And we want to get a positive 7t, so that would be a positive 10 times a negative 3. Those would be our factors. And so we'll say plus 10 minus 3, because if we add those two together that would give us a positive 7. And so that's our factored trinomial. Look at practice problem E. Factor that into two binomials. So first let's go ahead and set up our parentheses. That's usually what we want to do first. And put our y's here. Then we just look at that and we think of two factors of 45. If we added those two factors together, they would add up to 14. And that would be a positive 9 and a positive 5. So we'll say plus 9 plus 5. Remember, the order doesn't matter. We could have said y plus 5 times y plus 9. Does not matter. Let's do one more. X squared minus 11x plus 10. First, we'll set up our binomial pair. x, and x. And now let's think of two factors of 10 that if you added them together it would equal negative 11. So we've got a positive 10 and a negative 11, so that means we need to think of two negative factors. So a negative 10 and a negative 1, that's what would work. So we'll say negative 10, negative 1. And so that's our answer. So when you're factoring trinomials, just go ahead, first step, set up a pair of parentheses with your variables at the front of both of those sets of parentheses. Look at your constant term and think of two factors of that constant term. If you added them together, they would equal the coefficient of your single variable, your first degree variable, if you want to call it that. Put those two factors into the binomial. Check your work if you want to by expanding. And when you check your work, that just kind of proves to you how these steps work and how those apply to these problems. Sometimes you do these shortcut steps and you just kind of forget why they work that way. And that's why it's good to check your work from time to time. And that helps remind you how the process works. Okay, well that's all for lesson 69.